Good morning, guys. Welcome to cubic polynomial. So this is the last part of the polynomials chapter. The division algorithm for polynomials has been taken off from my syllabus. Though I am definitely going to upload a video based on that particular concept, because in case you are planning to pursue higher maths, you definitely do need the division of polynomials. So I will be doing that part also. But right now let us be learning about cubic polynomials. Now most of the chapter is devoted to quadratic polynomials. In the beginning, we study about linear polynomials, graphing part of it, and the cubic polynomials is like, they have just zoomed past cubic polynomials, but since it is there in the textbook, we will do one or two sums and the basic formulas of this particular concept. What is the general form of a cubic polynomial, or how do you identify a polynomial as a cubic polynomial? Whenever you have a polynomial and the highest degree of the polynomial is a 3, we say that it is a cubic polynomial, which I have already explained in the beginning of this particular lesson. So, if I have a polynomial, this is a polynomial that is given to you. So let us name this polynomial as p of x. What kind of a polynomial is this? You can see that the highest power in this case is here it is a 0. So it is a 4. So it is a quadratic polynomial. So suppose you have a polynomial like this. What is the highest power? Obviously you can see that it is a 3. This is a cubic polynomial. So whenever the highest power or the highest degree or the degree of a polynomial is a 3, we call it as a cubic polynomial. Now you know that every single type of polynomial, linear, quadratic, biquadratic, they all have a standard form. So the cubic polynomial also should have a standard form, and that standard form, when we are writing, should have a term having a power of 3, then having a power of 2, then having a power of 1, and then having a power of 0, which should be the constant term. That is the general form. Okay, so let us see how we can write down a cubic polynomial. So a cubic polynomial in x should have an x cube term, an x square term, x term, and a constant term. Correct? Just like the way a quadratic polynomial has terms in x square, x, and a constant term. So we represent the general form as ax square plus bx plus c, where c is the term which has got a power of 0. Right? Now, similarly over here, we join up these terms and we have a constant term also, and all these terms should have coefficients also. So we write it as random a, b, c, and the constant term becomes d. So ax cube plus bx square plus cx plus d. So going by this pattern, can I write the general form of a biquadratic polynomial in x? Let us see how it works. It should have a power of 4, it should have a power of 3, it should have a power of 2, it should have a power of 1, and it should have a constant term also. So I am going to write it here as a constant term. We will put the suitable variable over here. I need to give the coefficients also. I am going to pick out A, B, C, D. A, B, C, D. So I need a constant variable, so which is E. Ax raised to 4 plus bx cube plus cx square plus dx plus E. Got it? Going by this pattern, you know that you can write the general form of any polynomial of any degree. Okay? So the cubic polynomial, this is the general form. So what is the condition for this polynomial to exist? B can be 0. See, though this is the general form, it is not necessary that it should have an x square term, but mandatorily it should have the x cube term. So A cannot be 0. B, C, and D can be 0. Okay, now let us write down a few examples of cubic polynomials before we move on to the sum and product relationship. This is a general form of the cubic polynomial. It cannot be 0. So the question is, identify A, B, C, and D in the following list of polynomials. The first one, 3x cube minus 2x square minus x minus 1. Compare it with the general form, because you can see that the highest degree is the degree of the polynomial is a 3. Because the degree is a 3, we can say that it's a cubic polynomial. So when it is a cubic polynomial, you have to compare it with the general form of a cubic polynomial. So compare over here. You will get a is equal to 3, b is equal to minus 2, c is equal to minus 1 and d is equal to minus 1. Okay. Second one. What kind of a polynomial is this? This is again a cubic polynomial. So compare it with this part. So what is the value of a? A is the one standing with x cube. A is equal to 4. So what is the term standing with x square? You can see that there is no x square term. The reason being b is a 0. C into x. C becomes minus 2 by 3. And here there is no constant term. So d is also a 0. Right? Third one, minus 5x square plus 6x cube plus 7. The order is slightly jumbled. The cubic term has come in the middle, but it doesn't stop it from being a cubic polynomial. So what is the value of a over here? A is equal to 6. B is the one standing with x square, which is minus 5. There is no x term. So C is a 0 and D is a 7. Okay. Now, 8x cube plus 9x minus 7. So a is equal to 8. B is equal to 0 because there is no x square term. C is equal to 9 and D is equal to minus 27. So I now hope you are able to identify the values of the coefficients when a cubic polynomial is given. Now let us learn the formulas. So you don't have to learn any derivation. You just need to by heart the formulas of cubic polynomial. How many roots will a cubic polynomial have? So you know that depending upon the degree, the number of roots of a polynomial will change. A quadratic polynomial will definitely have 2 roots. Though the roots may be equal, the quadratic polynomial should have 2 roots or it will not have any root at all. So there is no question of a quadratic polynomial ending up with only 1 root. Similarly, a linear polynomial will have 1 root. So a cubic polynomial should have 3 roots. So let us call the roots as alpha, beta and gamma. Now let us see what is the relationship between these roots and the coefficients. So alpha plus beta plus gamma is minus b by a. Alpha beta plus beta gamma plus alpha gamma is equal to c by a. And alpha into beta into gamma is equal to minus d by a. Now one thing you need to remember over here is that the a, b, c and d for the cubic polynomial has to be properly taken by comparing it with the general form of the cubic polynomial ax cube plus bx square plus cx plus d, a not equal to 0. Okay, verify that 2, 1, 1 are the zeros of this given polynomial. Also verify the relationship between the zeros and the coefficients. So you can see that 3 roots are given. So automatically it has to be a cubic polynomial. And here you can find a cubic polynomial is given. So how do you verify a given number is a 0 of the polynomial? You substitute that number in the place of x and see whether we are getting the value of the polynomial as a 0. So let us put p of x. Let p of x is equal to x cube minus 4x square plus 5x minus 2. So what is p of 2? So wherever x is there, we substitute 2. 2 raised to 3 minus 4 into 2 raised to 2 plus 5 into 2 minus 2. You get 8 minus 16 plus 10 minus 2. So you get here minus 8. It's a 0. So you can see that 2 is definitely a 0 of this given polynomial. Now let us substitute 1 over here. So this is done. Okay. Now you need to find p of 1. What do you get for p of 1? 1 raised to 3 minus 4 into 1 square plus 5 into 1 minus 2. So 1 minus 4 plus 5 minus 2, which is minus 3 plus 3, which is a 0 again. So you can see that when we are substituting the value of 1 in the place of x in the given polynomial, we are getting a 0. So 1 is also the 0 of the given polynomial, and among the 3 roots, 2 roots are equal. So I don't need to substitute the third root over here again. We have already done it. So 2, 1, 1 are the zeros of the given polynomial. Let us identify the roots, or mention the roots as alpha, beta and gamma, and it doesn't really matter what you take as alpha, what you take as beta, or what you take as gamma. So what is the first relation that we need to check? Alpha plus beta plus gamma is equal to minus b by a is the first one that you need to check. So what is alpha plus beta plus gamma? My alpha plus beta plus gamma is 1 plus 2 plus 1, which is a 4. Correct. We need to check whether this is equal to minus b by a. So from the given equation, let me write down, this is the given equation. Let me write down the value of a, b, c and d. A is equal to 1, b is equal to minus 4, c is equal to 5 and d is equal to minus 2. Okay. What is minus b by a equal to? Minus b by a is equal to minus of minus 4 by 1, which is a plus 4. So you can see that alpha plus beta plus gamma is equal to minus b by a. So the first check is over. We do the second one. We need to see if alpha beta plus beta gamma plus alpha gamma is equal to c by a. So what is alpha into beta? 1 into 2 plus beta into gamma. 2 into 1 plus alpha into gamma is 1 into 1. So what am I getting? 1 into 2 is 2. 2 into 1 is 2. 1 into 1 is 1. So you get 5. Okay. Now we should see whether this is equal to c by a. What is the value of c? 5. What is the value of a? 1. So my c by a is equal to 5 by 1, which is a 5. So the second relation is also checked. Now the last one is alpha into beta into gamma is equal to minus d by a. So what is alpha into beta into gamma? As you can see that alpha into beta into gamma is equal to 2. So what is minus d by a? The value of d is a minus 2. The value of a is a 1. So minus d by a becomes minus of minus 2 by 1, which is a plus 2, which is the same as alpha into beta into gamma. So now you can see that all the three relations between alpha, beta and gamma and the coefficients have been checked for this particular question. So I hope this is a very straightforward question, actually a very easy one, except that little bit kuti calculations are there. That is all that is there. So I hope you are clear with this particular type of sum. Let us do a different type of sum over here now. Let us do a small recap here. You know how to write a polynomial when the zeros are given to you. So how did you write? I told you that k into x square minus sum of the zeros into x plus product of the zeros is the required polynomial. So this is a general form. Correct. When you give different values for k, you get different polynomials, and in the case of fractions, I told you how to take the LCM and write it neatly. Correct. So similarly, any kind of polynomial, if the zeros are given to you, you should be able to write, isn't it? So let us see what is the general form of a cubic polynomial when the zeros are given to you. How to write a cubic polynomial when the zeros are given to you. In the case of a quadratic polynomial, if alpha and beta are the roots, this was our required polynomial. K into x square minus sum into x plus product. But in the case of a cubic polynomial, we are having 3 roots and we have 2 types of sums. One is alpha plus beta plus gamma and alpha beta plus beta gamma plus alpha gamma. 2 types of sums are there. This is a complicated one. This is a very simple and straightforward one. So I am going to use the exact terms that I said right now so that you can remember the equation more clearly. It is k into, x cube. X cube minus simple sum into x square plus complicated sum into x minus the product. And one more thing you need to remember is that, see the sign plus minus plus. Same plus minus plus minus. Alternate signs for alternate terms. Okay. So our required polynomial is k into x square minus simple sum into x square plus complicated sum into x minus the product. Okay. Or in other words, k into x cube minus alpha plus beta plus gamma into x square. The complicated sum is this, alpha beta plus beta gamma plus alpha gamma into x minus alpha beta gamma. So If alpha, beta and gamma are given to you, you can write the polynomial. So this is our general form, and just like in the case of quadratic, for different values of k, you get different cubic polynomials. Normally, when we write, we take k as 1 and then write it off. Okay, so let us do a sum and see whether you can apply this particular concept. Write a cubic polynomial whose roots are 3, 5 and minus 7. So let us identify the roots as alpha, beta and gamma. So let alpha is equal to 3, beta is equal to 5 and gamma is equal to minus 7. Okay. So first we find the simple sum alpha plus beta plus gamma, which is 3 plus 5 minus 7, which is 8 minus 7, which is a 1. Now we find the complicated sum, which is alpha beta plus beta gamma plus alpha gamma, which is 3 into 5 plus 5 into minus 7 plus 3 into 7. So you get 15 minus 35 plus 21. Correct? It's a plus 1. And alpha beta gamma is 3 into 5 into minus 7. So you get here 15 into minus 7, which is a minus 105. Okay, so we got the simple sum, the complicated sum and the product. Now let us apply it on to the required format. So the general form is x square minus simple sum into x plus complicated, x cube minus simple sum into x square plus complicated sum into x plus product. Okay, product. This is k into x cube minus, what is the simple sum? 1. 1 into x square plus complicated sum is again a 1 plus product. So that is a minus 105. After writing this, please mention this is a general form of the required cubic polynomial. So when we put k is equal to 1, what do we get? So when, and after writing this, see, when you are writing it in the answer sheet, say that this is a general form of the required cubic polynomial. For different values of k, we get different polynomials. Then you say when k is equal to 1, p of x becomes x cube minus x square plus x minus 105. And end it over there. Always make sure you write the general form using k and say that for different values of k, we get different polynomials. If it's quadratic, you write different quadratic polynomials, or cubic, you write different cubic polynomials. Then you put k is equal to 1 and then show them. This is what happens. Okay? I hope you are very clear with this. It is a direct application again. It's a straightforward sum. We have done many sums in quadratic polynomials in the same way. Again, I am repeating, write the general form, mention it is a general form, write for different values of k, we get different polynomials, and put one value of k, basically 1 over there, and write it. If you are getting a fraction over here, directly take the LCM and apply it over there. This also I have shown you. Find the condition to be satisfied by the coefficients of the polynomial fx is equal to x cube minus px square plus qx minus r when the sum of its two zeros is a 0. So which means that a cubic polynomial is given to you and the coefficients which we identify in this question as 1, minus p, q and minus r has to satisfy a certain condition so that the sum of its two zeros is a 0. Okay, a slightly more complicated sum than the previous one, but let us see how we can crack this. The polynomial that is given to us is x cube minus px square plus qx minus r. If we compare this with the general form, we will get a is equal to 1, b is equal to minus p, c is equal to q and d is equal to minus r. So this part I hope you people are very clear. Now it is given that the sum of its two zeros is a 0. So normally what do we take as the zeros of the given polynomial? It is alpha, beta and gamma. So the roots or the zeros are alpha, beta and gamma. It is given that the sum of its two zeros is a 0. So, in alpha, beta or gamma, take your pick. Any two zeros you take. If you want to take alpha and beta, you take alpha and beta. Or you take beta plus gamma is equal to 0. Take it that way. Or alpha plus gamma is a 0. Take it in that way. I am going to take the sum of alpha and gamma is equal to 0. This is already given to us in the question. Okay. Now we need to find the condition or the relation between the coefficients that gives us this particular situation. Okay. Now, what are the other things we need? We know about a cubic polynomial. We know how to write out a cubic polynomial, which is of no use over here. We know three formulas which relates the roots and the coefficients, which is alpha plus beta plus gamma is equal to minus b by a. Okay. Now, I am going to apply whatever I know over here. Alpha plus beta plus gamma. What is alpha plus gamma? It is 0. So, I know that 0 plus beta is equal to minus b by a, or I can say beta is equal to minus b by a. Correct. What is the value of b over here? B is a minus p. So, minus b becomes minus of minus p. Value of a is a 1. So, I get beta is equal to p. Okay. Now, what is the other relation? See, whenever you are doing the formula based sums like this on cubic polynomials, do the simple sum first, do the product second, and then do the complicated one the last. You know, it's easy. Complicated sum should always stay last. So, do this alpha plus beta plus gamma first. Then you do alpha into beta into gamma. For this kind of sums, I mean. Okay. So, alpha into beta into gamma, can you say what will be the value? Alpha into beta into gamma is a minus d by a. What is the value of d? Minus r. Minus d will become plus r by a. So, we will get r by 1, which is an r. Okay. So, this is gamma and this is r. So, I am putting one horn like thing over there so that you can identify it as a gamma. So, alpha into beta into gamma is equal to r. Okay. Now, let us do the complicated one, which is alpha beta plus beta gamma plus alpha gamma is equal to c by a. So, which is q by 1, which is a q. Okay. So far, we have gotten beta is equal to p, alpha into beta into gamma is equal to r, and this is equal to q. So, before proceeding with the sum, so even I was getting confused by gamma and r. So, I have changed r over here to this. Okay. So, I hope you are fine with it. So, now let us see how we can proceed with the sum. We know beta is equal to p. So, this part is equal to q. Can we further simplify it? You can see that beta is common in these two terms. I know the value of alpha plus gamma. So, if I am taking beta out, I will get in the bracket alpha plus gamma plus alpha into gamma is equal to q. So, alpha plus gamma is a 0. So, this term vanishes. I will get alpha into gamma is equal to q. Okay. So, I get alpha into gamma is equal to q. I know beta is equal to p. I also know alpha beta into gamma is equal to r. Alpha into gamma is a q, beta is a p, or I get the relation between the coefficients as p into q is equal to r. I have an equation relating p, q and r only, and this is a condition that should be satisfied by the coefficients so that the sum of its two zeros is a 0. What did I do over here? Whenever you are given a cubic polynomial or a quadratic polynomial, the first thing that you need to do is write down the information that you are having. So, whenever you have a polynomial, compare it with the standard form and write down the coefficient values a, b, c, d. Once you write it down, you mention the roots as alpha, beta, gamma or alpha, beta depending upon whether the polynomial is a cubic or a quadratic one. Then you write down alpha plus beta and alpha beta for quadratic or the 3 relation for a cubic one. So, when I wrote it down here, I got alpha plus beta plus gamma is minus b by a. In the question, it was given the sum of two zeros is a 0. So you see, any two zeros you can take. It doesn't matter. You can take alpha plus beta is 0 or beta plus gamma is 0. I took alpha plus gamma is a 0. When I applied it over here, I got beta is equal to p. Okay. Then I wrote alpha into beta into gamma is equal to r. I could not do anything with it at that point of time. I left it there. I wrote the complicated sum. I got that is equal to q. But here I knew if I took beta outside, it's like manipulation. I will get alpha plus gamma inside the bracket, which I can put as a 0. I will get alpha into gamma is a q. The two information that I gathered from these two, I applied in the third one. Alpha into beta into gamma is equal to r, and I got the relation. Okay. This is just one way of doing this sum. Can you guys think of an easier way? There is a very easy way to do this sum. This is also not so very difficult, but it requires a little manipulation, so slightly complicated. So there is a very easy way. Once you get beta is equal to p, what is beta actually? Beta is a 0 of the polynomial. 0 of the polynomial means if I am substituting beta in the place of x, I should get a 0. I got the value of beta as a p, which means that if I am putting p in the given equation, I should get a 0. So I am going to substitute p in the place of x over here and see what I am getting. I will get f of p, or this is f of beta, which is f of p, is equal to p cube minus p cube plus p cube minus r, and I know that because beta is a 0, this is equal to 0. P cube and P cube got cancelled. I will get PQ minus R is equal to 0 or PQ is equal to R. This is definitely a simpler way of doing this particular sum rather than going for this manipulation. But then whenever you are studying a particular concept and you are getting a sum in a particular way, or somebody is doing a sum and showing it, you see this is the way in which you should do this sum. It's fine. That method might be correct, that method might be easier, but think in your own way. There are multiple ways to do a particular sum. Maybe not all the sums, but most of the sums, especially in geometry, in chapters like lines and angles or triangles or circles for that matter. So many different ways of doing a particular sum. So please think and figure out your way, your way of thinking, and if it is a right way. Do not follow somebody else's method, because in the examination it is not going to help you at all. So this sum I have done it in two ways. See whether you can manipulate this particular sum in a different way and get the same answer. If two zeros of a polynomial x cube minus 4x square minus 3x plus 12 are minus root 3 and plus root 3, find the third zero. So what is the basic concept of the zeros is that if I am substituting minus root 3 or plus root 3 in this particular polynomial, I will get a 0. But this is not going to help me find the third zero. Okay. So we are going to make use of the knowledge of the formulas of alpha, beta and gamma. So I am going to take alpha is equal to minus root 3 and beta is equal to root 3. I need to find gamma. So what is alpha plus beta plus gamma equal to? I know that it is equal to minus b by a. A is equal to 1. B is equal to minus 4, C is equal to minus 3 and D is equal to 12. Correct. Minus B by A will give me minus of minus 4 by 1, which is a plus 4. I am going to substitute over here. I got the third root as a 4. An extremely simple sum. Maybe it might come for a 1 marker. So direct substitution by using the simplest formula, which is alpha plus beta plus gamma. In this case, you can also use alpha into beta into gamma also. You will get the same answer. Find the zeros of the polynomial fx is equal to so and so. If given that the product of its two zeros is 12. So it's a cubic polynomial, it has 3 zeros, but they are telling that the product of its two zeros is 12. So among alpha, beta and gamma, take any two roots, whichever one you like, and write its product as 12. So alpha, beta and gamma are the roots. I am going to take beta into gamma is equal to 12. Okay. Now I need to find the particular values of alpha, beta and gamma over here. So what is my polynomial? The polynomial is a x cube minus 5x square minus 2x plus 24. I told you, as soon as you get the polynomial, please write down the coefficients. So A is equal to 1, B is equal to -5, C is equal to -2 and D is equal to 24. So let it be in this box. Now I told you the next step will be to write down the relation between the zeros and the coefficients. So alpha plus beta plus gamma is equal to minus b by a, which is 5. Alpha beta plus beta gamma plus alpha gamma is equal to c by a minus 2 by 1, which is a minus 2, and alpha into beta into gamma is a minus d by a, which is a minus 24. Put this in another box. So we have sorted out whatever we know from the question that is given to us, and it is written over here. Now starts the actual manipulation of the sum in order to get the answer. What information we have? Beta into gamma is equal to 12. You people are taking alpha into beta is equal to 12 or alpha into gamma is equal to 12. Doesn't matter at all. Okay. So beta into gamma is 12. Can I substitute anywhere over here? In the first equation, I cannot substitute. As you can see in the third equation where alpha beta gamma is equal to minus 24, I can substitute beta into gamma is 12. So I will get alpha into 12 is minus 24, giving the value of alpha as a minus 2. So here we have obtained very easily the value of alpha being equal to minus 2. Now our job is to find the values of beta and gamma. After getting the value of alpha as a minus 2, I can substitute it in the first equation where alpha plus beta plus gamma is a 5. Then I will get beta plus gamma is 5 minus alpha, which will give me 7. So now I have a relation between beta and gamma, which is beta plus gamma is 7, and another relation between beta and gamma, which is beta into gamma is equal to 12. Gamma plus beta is 7. Gamma into beta is 12. We know. Gamma plus beta 7 gives us gamma is 7 minus beta, which I can substitute in this particular equation, giving 7 minus beta into beta is a 12. I open the bracket in order to get a quadratic equation. I am getting beta minus 4 into beta minus 3 is a 0, for which I get beta is equal to 4 or beta is equal to 3. Now what happens when beta is equal to 4? My gamma becomes 3 because beta into gamma was 12. Okay. In this case, beta is equal to 3 means gamma is equal to 4. Actually, the values are interchanged. See, you need to understand that beta and gamma are just variables we use for the root, which basically means there are 3 roots. Out of that, one root is 4 means other root is 3, or one root is 3 means other root is 4. So, the values are valid. So, my first root alpha is a minus 2, the second root is a 3, and the third root is a 4. Or the second root is a 4 and the third root is a 3, it doesn't make a difference. Be very clear why we are using alpha, beta, gamma. They are just normal variables. Instead of writing first root, second root and the third root, we are using alpha, beta and gamma. A slightly long sum, too much of calculations also. So even if you are getting the sum, let us hope that you are getting it for 4 or 5 mark accordingly as is the marking in your question paper. So now we are done with cubic polynomials. Let me make a small mention about the graphing of cubic polynomials. You don't need to know how to graph them, just to read the basic, which is the zeros of the cubic polynomial. Here, as you can see, I have roughly drawn the graph of 3 polynomials. So you know that whenever the polynomial or the graph of the polynomial touches the x-axis or crosses the x-axis, we identify that part as a 0. So whenever you are doing the sums related to the graphs of quadratic polynomials, you know that you have to find 2 zeros or there will be no 0. The quadratic polynomial or the quadratic equation is unsolvable. In the case of cubic, it has to touch the graph at 3 points. But if it touches the graph at 2 points, can we say it is not a cubic polynomial? Look at this particular graph. See here, this is touching distinctively at 3 points. Okay. Look at this graph. Only over here and over here. This is the graph of a cubic polynomial. Only difference is that these 2 zeros here they are equal. See, in the previous sum, we dealt with 0 of 2, 1 and 1, right? If you are drawing the graph of that particular polynomial, it will touch the x-axis only at 2 points because the two zeros are equal. Okay, similarly, look at this one. This is the graph of x cube, which is a cubic polynomial, all the three zeros being equal. So, in the case of a cubic polynomial, it can touch at 1 point, 2 point or 3 point, but the maximum will be 3 points. Now, when you are given this particular graph, or let us say this particular graph, how will you identify this as a quadratic or a cubic? Look at the turn, the u part of it. For a quadratic, there will be only one u part. In the case of a cubic polynomial, there will be more than one u part. Like in the case of this is considered to be one u and then going upwards. Okay, that is how you identify a quadratic and a cubic polynomial roughly from the graph. But don't worry too much. They will not ask you such complicated questions. Just for your information, I just told you that count the turn. Otherwise, just see the places. They will mention, something about what kind of a polynomial it is, and then you can understand it. Okay.